How does the source communicate the advertised current limit to the sink? Let's jump into the USB Type-C cable and connector specification to find the answer. Figure 436 shows the pull-up, pull-down CC model of the connection between the source and sink. A USB Type-C cable has a CC wire that is connected to either the CC1 or CC2 pin in the receptacle. When the cable is plugged into the source and sink receptacles, the CC wire is used as the communication channel. As stated on page 227 of the spec, the source adjusts RP to advertise which of the three current levels it supports. The sink then decodes the advertisement by tracking the voltage across the RD resistor. That's it. The advertised current limit is determined by a simple resistor bridge. Table 427 provides the mapping between RP and advertisements. Table 428 provides the three possible RD implementations for the sink. The formulas needed to decode the advertisement are provided on page 250. Table 436 provides the CC pin voltage range for each of the advertisements, assuming the sink uses the RD plus or minus 10% implementation. To verify our understanding of these tables and the pull-up, pull-down CC model of figure 436, let's now look at the calculation of the minimum VRD USB voltage and the maximum VRD 3.0 voltage given in table 436. VRD USB has a minimum of 277 millivolts and a maximum of 612 millivolts. This means that if a source is connected to a sink with an RD plus or minus 10% implementation and the voltage across the RD resistor falls within this range, then the sink knows that the source is advertising the default current. In general, the sink does not know the source implementation. That is, it does not know which of the three columns in table 427 is being used. Thus, we must calculate the voltage using each of the three possibilities and then take the minimum and maximum to define the range. I've colored the cells used to calculate 277 millivolts green. Working backwards, cell Q4 takes the minimum of the three possibilities and shows that 277 millivolts is achieved when a source uses a 3.3 volt plus or minus 5% supply. Jumping into cell K9 shows the voltage over RD resistor min formula. V source min is 3.135 volts. V offset max is 250 millivolts, i.e. the maximum voltage drop for a cable. RD min is 4.59 kiloohms, and RP max is 43.2 kiloohms. VRD 3.0 has a maximum of 2.042 volts, and the cells used to calculate it are colored red. Cell R6 takes the maximum of the three possibilities and shows it is achieved when a source uses a 4.75 to 5.5 volt supply. Jumping into cell L5 shows the VRD res max formula. V source max is 5.5 volts, RD max is 5.61 kiloohms, and RP min is 9.5 kiloohms. In today's video, we set out to answer the question, how does the source communicate the advertised current limit to the sink? The answer turned out to be surprisingly straightforward and can be summarized in three topics. Number one, the source implements a current source or resistor pull-up to a voltage source as specified in table 427. Number two, the sink implements a pull-down resistor or voltage clamp as specified in table 428. And three, the sink applies the formulas provided on page 250 of the USB Type-C cable and connector specification to decode the advertisement. In the next video, we will jump back into hardware design and discuss some components our sink could use to decode the advertisement.